Hello, students. This is Mr. Ezra. Today we are going to talk about quadratic applications, building and solving quadratic functions. It's going to be awesome, and let's get started. So we're going to have lots of different types of questions today, several different examples. The first one says the product of two consecutive positive integers is 132. And part A says write an equation to model the situation. So we need an equation. That's what we're looking for here. And two consecutive means that they are in order. So like 5 and 6 are consecutive because 6 comes right after 5, and 7 would be the next consecutive number, and then 8. So we're looking for two consecutive numbers that multiply, because the word product means to multiply, doesn't it? So we're looking for two numbers that are consecutive that multiply to give us 132. So some of you may be doing like factors of 132 to try to figure this out, but we need an equation. So let's let the first consecutive number be a variable called x. And then we'll let the second number be another variable, but if it is consecutive, it means that it's one more than the one that comes before it. So like if 5 is a number, and then 6 would be the next consecutive positive integer. So 5 plus 1 is 6. If we needed another one, it would be 5 plus 2 to get to 7, or then 5 plus 3 to get to 8 if we needed 4 consecutives, but we only need 2. So the second one is going to be x plus 1. Because the first one's x, the second one is going to be consecutive. It's going to be one more. So we have these two expressions here. One stands for the first integer, the other stands for the second, and we need to find the product of them. So we're just going to multiply them together. X times x plus 1. And we know that when we multiply them together, we get 132. Now let's clean up our equation a little bit by multiplying x times x and x times 1. We get 132. All right, well, that is an equation. There are other ways that we could write it. We could subtract over the 132. We could have left it in the original x times x plus 1. So we have something like this. We have an equation. And now it says, what are the two consecutive integers? Well, in order to find the two consecutive integers, we're going to take this equation that we just found. We're going to solve for x. Now, there's lots of ways that we've talked about for solving x when you have what's called a quadratic, when you have an exponent of 2. I'm going to try to factor this. I'm going to move 132 to the left by subtracting it on both sides of the equal sign. Okay, so minus 132 on the left, and when I subtract it from itself, it goes away, it becomes 0. And now I'm going to factor this. So this is factoring when x squared has a leading coefficient, has an a of 1. Which means that I need to look at the signs, because I know I'm going to start with x times x to get x squared. The last sign here is negative, which means my signs are opposites. So I've got to multiply a positive times a negative to get to 132. And now I'm going to look at factors of 132 and see which ones work. I know that the smaller one has to be negative because I'm adding to get, I'm going to add the inside and outside to get a positive. So I look at -1 and positive 132, and that doesn't work. That doesn't add to give me 1, -2 and 66. That didn't work. -3 and, let's see, 44. That didn't work. Let's see, does -4 go into it? So I get my calculator out and try 132 divided by 4. Yes, 33 times. I'm still not anywhere close to 1, am I? That's my goal. Remember, your goal is the B term. So my goal is a sum of 1. And that one didn't work, that one didn't work, that one didn't work, and that one didn't work. So we've struck out so far several times. So we will try 5 does not go into 132. 6 does. How many times? 22 times. Still not there. Does 7 go into 132? It does not evenly at least. And 8 does not evenly. Does 9? 9 does not evenly. So you see what I'm doing here? I'm just kind of going through these until I get to something that works. 10 doesn't. 11 and 12 do. So minus 11 and positive 12. So far I've been checking these to see if they work. Add these together, negative 6 plus 22, not 1, but negative 11 plus 12 is 1. That is the combination that I'm looking for. That's the winner, winner, chicken dinner. So it's going to be a positive 12 and a negative 11. Now remember, whenever you do this, just to make sure, you can always refoil this to check to see if it gives you the quadratic that you started with. But the goal is to have it factored, and from the factors to get the two solutions. So if I set x plus 2 equal to 0, I get negative 12 as my first solution. When I set x minus 11 equal to 0, I get positive 11 as one of my solutions. And remember that in this problem, it asks us to find two consecutive positive integers. Well, one of these integers is positive and the other is not, so I'm going to have to go with the positive integer and use that one. The other one, in this case, just is not going to work because it's not positive. So, what are the two consecutive integers? Well, the integers are 11 and the next number after that, 12. So we'll say 11 and 12. Dot. All right, something like that. So first we made an equation by multiplying the product of some unknown number and the number that comes right after it. And after doing that, we got a quadratic that we were able to then solve by factoring to get our two integers. Example number 2, solve s equals 2 pi r squared plus 2 pi r h for h. So anybody kind of looking at this and scratching their head and thinking, what am I getting myself into here? Well, this really isn't going to be as difficult as long as you don't let your brain freak out. It's going to be okay. It really is. I like to kind of highlight what I'm trying to get by myself. In this case, it is an h. I'm solving for h. I want everything else on the other side of the equal sign. So if I said, let me just rewrite this, s equals 2 pi r squared plus 2 pi r h. And there are probably a few ways to do this, so don't ever think that the way that I show you is the only way. But our goal is to get h by itself, and the easiest thing the easiest first step, I think, is going to be to get rid of this term that does not have an h in it. And since it's all products of 2 and pi and r squared, it's all kind of one term, one thing. I can subtract that whole thing from the other side of the equal sign. So really I'm subtracting it on both sides. On the left side, I'll have s minus 2 pi r squared. And on the right side, when I subtract 2 pi r squared, it'll cancel out from the 2 pi r squared that's kind of on here on the left. And the other term that's part of this sum here is just going to stay there on the right side. It's going to be 2 pi r h. Okay. Now, when you're multiplying 2 times pi times r times h, it's like I'm multiplying all of 2 pi r times h, and my goal is to get h by itself. So to undo that multiplication of all these things multiplied by h, I'm going to divide both sides of the equal sign by 2 pi r. On the left side, I'm going to divide, and that'll give me s minus 2 pi r squared over 2 pi r. I'm going to divide on the left side. On the right side of the equal sign, when I divide by 2 pi r, it's going to cancel that out and leave me with just h. And I have solved for h. Okay, so that's one answer. H equals s minus 2 pi r squared over 2 pi r. And I could circle that and say, hey, I've done it. H is by itself. I solved for it. Now, it is possible to break this into two fractions. So we could say that h is equal to s over 2 pi r minus 2 pi r squared over 2 pi r. And if we were to break this apart, the s over 2 pi r cannot reduce anything. But we can see with this fraction on the right, the 2 cancels out, the pi cancels out, and r squared divided by r doesn't completely cancel out, but one of the r's does, leaving behind an r. So this would be an alternate possible solution. And I mention this because if you're dealing with a multiple choice question and you get to this and the answers don't look like this, they look like they've been separated apart, that means that you need to go to the next step and separate them. But either answer would be acceptable on an open response test. I would accept both of them. Example 3, you drop a ball off a cliff at 320 feet. How long does it take the ball to hit the ground using the function h of t equals negative 16t squared plus h sub 0? Now, remember in mathematics, this sub 0 is like a starting amount, an initial value. So h sub 0 is going to be the height at the start, when you first drop the ball. So when we drop the ball, we're kind of standing on a cliff, aren't we? That's 320 feet high. And we're at the top of that cliff, and we're standing there, and we drop the ball. Okay, so we drop the ball, it's going woo, and it's going to end at the base of the cliff at a height of 0. All right, so in order to solve this, we have to think about these things, that the initial height is 320, that's h sub 0, and that the height after it hits the ground, the h sub t, is going to be 0, because that's how long does it take the ball to hit the ground. So once we plug these things in, we're only going to have one variable left behind, right? So we got 0 is equal to negative 16 t squared plus 320. All right. Now, in this case, I'm probably not going to factor since I only have a t squared. Instead, I am going to solve using the square root method. I'm going to subtract 320 from both sides of the equal sign so that I move it across the equal sign to the left. So minus 320 on the right cancels out. 0 minus 320 is negative 320. This negative 16t squared is still there, so I've canceled this out on the right and moved it to the left by subtracting. Now I'm going to divide both sides by negative 16, so negative 320 divided by negative 16 gives me 20. So t squared equals 20. And there's nothing wrong with the t squared being on the right, but I kind of like for it to be on the left, so I'm just going to move over here and move that to the left side using that reflexive property of equality. And now I'm going to take the square root of both sides. So when I take the square root of t squared, it cancels out with the squared, and I'm left with just t. The index and the exponent cancel each other out, and then we get positive or negative square root of 20. Now, this is an application problem. And what that sometimes means is you don't have to leave your answer as a radical, because it doesn't really make sense. Like if someone says, how long is it going to take the ball to hit the ground? And you say, push up your glasses, it'll be 2 root 5. And they're going to say, what? You need to give them a decimal answer. So this is where it is appropriate to get your calculator out and take the square root of 20 and find out what it is approximately. So I'm going to put a little squiggle here, and that means approximately is about, and it's going to be 4.472 blah, blah, blah. Keeps going on forever and ever, is the decimal approximation. Now, I'm going to drop off the minus sign. And why am I going to do that? Again, this is an application problem, and we have to think about this as an application problem. Algebraically, there are two solutions, a positive and a negative. But in the context of the problem, when you throw this ball off, drop this ball off the cliff, and it's going down towards the ground, we're measuring time here. And there's no way that this amount of time can be negative, because that's kind of crazy. It doesn't work that way. Time doesn't move. You can't throw a ball from the top of a cliff and it hit the ground before you threw it. You know what I'm saying? So the negative is, in this case, not even useful. We don't need it. We can ignore it. And we get positive 4.472 seconds is what it doesn't say in the problem, does it? But this is measured in seconds. Right, so 4.472 seconds is our answer. Our fourth question, Hugh Betcha launched a model rocket with an initial speed of 88 feet per second. After how many seconds will the rocket be 40 feet high? So this 40 feet is at the end, and this 88 feet per second is the initial velocity. And I didn't explain the variables here, but I will go ahead and explain as we're going through this that V stands for velocity or speed. Okay, so V is going to be equal to 88 feet per second. Okay, time, we don't know. That's the question. It's asking how much time. And H of t, that's the height at the end of it. Right, so we want to know how long is it going to take it to be 40 feet high. All right, so we know that we can plug in 40 for H of t. Negative 16t squared plus, and then V is going to become 88. And then t is still a variable. We don't know the answer for that. So here we have a quadratic. 40 equals negative 16t squared plus 88t. We want to solve this quadratic. Well, the first thing that I want to do probably is to try to factor it. And to factor it, I need a leading coefficient that's positive, and I need everything on the same side of the equal sign. So instead of subtracting 40, which may be your first kind of inclination, is to take that 40 to the right, because you only have to add or subtract one number that way, it's probably going to be better if we take the two variable terms to the left of the equal sign so that we end up with a positive 16t squared. So I'm going to add 16 to the left. I'm going to subtract 88t to the left. And this positive 40 is already on the left, putting those in descending order. On the right side, after adding 16t squared and subtracting 88t, we have 0 left behind. Now, the first step of factoring is to look for a common factor. So I'm going to ask myself, what divides evenly into 16 and 88 and 40? Right, so you may think 4 goes into all three of these terms, but 4 is not the largest number that divides into each of them. 8 is, so we're going to factor out an 8. 16t squared divided by 8 is 2t squared. Negative 88t divided by 8 is negative 11t. And 40 divided by 8 is positive 5. Okay, now the 8 is factored out, and I'm going to have to deal with a leading coefficient that is greater than 1, which means I need factors of 2. I'm going to use 2 and 1. And factors of 5. It's either going to be 5 and 1 or 1 and 5. My signs are, when I look at this, I see a positive here, which means they're the same. I come back here, that means they're both negative. So I know it's going to be either a negative 5 and a negative 1 or a negative 1 and then a negative 5. Remember, you keep the first numbers in the same order, especially if they're prime here, so that you only have to worry about changing one of the two pairs. All right, so we do the inside and outside trick to test to see. So this is kind of like the outside and inside of FOIL. 2 times negative 1 is negative 2. 1 times negative 5 is negative 5. When I add those together, I get negative 7. That is not B. My goal is B, negative 11. So that didn't work. Outside here is negative 10. And inside is negative 1. And negative 10 plus negative 1 is negative 11. That is what I'm looking for. So this is the combination that I want. Order is important when you use this method. So I need to plug the 2 and the 1 at the beginning of the parentheses as 2t and 1t. Now I don't have to write 1t, I can just write t. And then the negative 1 and the negative 5 need to be at the ends of both parentheses in that order, minus 1 and minus 5. We have 2t minus 1 and t minus 5. I'm going to solve both of those to get t equals, let's see, 1 over 2. And t equals 5. Now, we've kind of just been thinking about the algebra of this, but maybe we should have drawn a picture to start with. Certainly we can draw one now. So Hugh Betcha has launched a model rocket. So he's got this rocket, and I'm going to just kind of like draw a little rocket here. Here's his rocket. And he launches this thing, and it goes up into space, right? Does it keep going forever? Well, no. Eventually it kind of like changes direction and comes back down to Earth until it hits the Earth, right? So when it says how long is it going to take it to get to 40 feet high? Well, let's say that this is 40 feet high, right here. This is 40 feet high. Well, can you see why we have two positive answers? Because it's going to reach 40 feet high after a half second, and then it's going to keep going up, and then turn around and start falling, and then it's going to reach it again after 5 seconds. So it reaches that distance first after a half second. That's 1/2 second. And then keeps going up and then starts to fall. And after 5 whole seconds, it is back at 40 feet again. Okay. Well, this question is saying after how many seconds will the rocket be 40 feet high? And we can either say, well, it's going to take a half second for it to get there, or we can be kind of like a smarty pants and say, it's going to get there after a half second, and then again, it's going to be at 40 feet after 5 seconds, okay? So I'm just going to say at 1/2 second, the rocket will reach 40 feet high. And I'll just be confident in my knowledge that it will be 40 feet high again on its way back down towards the Earth. Question number 5. A ball is thrown into the air from a height of 4 feet at a time of 0. Initial time of 0. The function that models this is provided, where t is measured in seconds and h is the height in feet. What is the height in the ball after 2 seconds? Well, if we have this function h of t equals negative 16t squared plus 63t plus 4, and it says, well, what's the height? That's the h of t, right? What's the height after 2 seconds? Well, you're going to plug in 2 seconds to the function to find that height. Essentially, we want to know h of 2 seconds. So negative 16 times 2 squared plus 63 times 2 plus 4. This might be a good opportunity for you to just put all that in your calculator. You can try to do it in your brain. I don't have a problem with that. But I'm going to use my calculator here. It might take me just a second. So I've got negative 16 parentheses 2 close parentheses squared plus 63 parentheses 2 plus 4. 66 is what I got. So 66 what? Remember that this is height in feet, right? So 66 feet. When will the ball reach a height of 50 feet? Well, this is asking a different question. So we're using the same function, but this time instead of being given the time, we're given the height. So it says after 50 feet. That's h of t. What's going to be the time? Well, this one, we're not going to be able to just plug and chug. Instead, we're going to have to solve this quadratic. All right, so 16t squared minus 63t plus 46. There's nothing that factors out of it, and I'm pretty sure that trying to factor it is going to be really difficult. So we're just going to use what's called the quadratic formula. So remember, with the quadratic formula, you identify a equals 16, b equals negative 63, and c equals 46. And then you plug those into that wonderful formula that you have memorized, which is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Probably going to get some big numbers, but I'm going to speed up through this and see if we can get our answer. All right, so remember that when we're working on these problems, we've got 63 plus or minus the square root of 1025 is the discriminant over 32, and we actually need numbers that people can use, so I just got the decimal approximation of that and use that decimal approximation, or you can leave it as 63 plus root 1025 divided by 32 in your calculator and then subtract it, and you should get something really close to 3 seconds and something really close to 1 second. So we're going to round those to 3 seconds and 1 second. And remember that this is a ball that's thrown into the air. So it's starting at a height of 4 feet. That's 4 feet off the ground. And it's thrown. And it's going to hit the ground. So it is going to reach 50 feet, go past 50 feet, and then go back down through 50 feet again. So it's going to hit 50 feet 2 times, which means we're going to have 2 answers here. So it's going to reach 50 feet at 1 second approximately, and then again it's going to reach it at approximately 3 seconds. So we can answer that question by saying something along the lines of 1 second and again at 3 seconds. And these are approximations. So I should say about 1 second, really. Okay. When will the ball hit the ground? All right, well, it's going to hit the ground. That means the height is going to be 0 instead of 50. So we got 0 equals negative 16t squared plus 63t, oops, plus 63t plus 4. Again, we're going to use the quadratic formula because I think that's going to be the easiest thing to do here. And I'm just going to speed through it and see at the end of it. All right, so we've come out the other side of the quadratic formula, and when I plugged the negative 63 plus root 4225 over negative 32, I got this negative answer. When I used the minus sign, I got positive 4, and remember these are both in seconds. Well, which one of them is not possible? That's right, the negative. Now think about the context. Why is it not possible? Well, we started the ball at 4 feet. So it's only going to reach 0 one time because it has to go up and back down past 4 to get to ground level, which is 0. So 4 seconds is the correct answer. So it's going to reach it after 4 seconds. Last question of the day in this super long video. A scuba diving company currently charges $100 per dive. On average, there are 30 customers per day. The company performed a study and learned that for every $20 price increase, the average number of customers per day would be reduced by 2. So for this last question, number 6, I just went ahead and worked it out, and we're just going to talk about it really quickly because this video is shaping up to be a very, very long one. So what we have here is a scuba diving company that's charging $100 per day, and they've done some research and they realized that for each additional $20 that they charge people for a dive, then the average number of customers per day is going to be reduced by 2. So thinking about this and putting it in a table, they looked at the price per day. If there was not a price increase, they have 30 customers, they are making $3,000. But if they add $20 per dive, their new price is going to be $120. They've lost 2 customers, but they're actually going to make a little bit more money. If they go up another $20, so that would be 2 times 20 or $40, they're now at $140 per dive. Their customers has gone down $2. And again, they're doing okay. They're making more money. And this trend of making more money is going to continue if we keep this pattern going. After 4 days, they're going to be getting $180 per dive, only have 22 customers, but they're going to net $3,960. Well, the second part here after filling out the table is to identify the formula that relates back to this situation by using x as the number of price increases instead of 1, 2, and 3. So you might have noticed that we had 100 plus 20 times the number of price increases. That's 100 plus 20x for the price per day. The number of customers is 30 customers minus 2 times the number of price increases, so 30 minus 2x. I had to multiply those two things together, FOILed them, and eventually ended up with negative 40x squared plus 400x plus 3,000. And this is the formula that relates the revenue that they make after a certain number of price increases as indicated by the variable x. Part D, which skips over part C, not sure why. So part D says, at what price would they make no money at all? Well, making no money at all means that their revenue is $0. So I set that equation that I just got, or that function that I just got, negative 40x squared plus 400x plus 3,000, and set it equal to 0. And at first I was thinking, well, I got to get this first part to be positive, and then I looked at all three of these numbers and realized they were all divisible by 40. So by factoring out a negative 40, I was able to divide each three of these terms by negative 40, and I ended up with positive x squared minus 10x minus 75. And now I've got a leading coefficient of 1. It's actually something that's not too difficult to factor, giving me x plus 5 and x minus 15. The negative 40 does not have a variable, so as far as factoring and solving, once I get the factors, I can ignore it. And I focus on just the things that have x's. And I got negative 5 as a solution and 15 as a solution. Well, remember, this is a real-world problem. You can't have negative 5 price increases. That doesn't make sense here. So we're only looking at the 15 price increases. And it says, at what price would they make no money at all? Well, 15 is the number of price increases. That's the x, right? Well, after 15 price increases, they would be charging or having a price per dive of 100 plus 20 times 15, or $400. So if they start charging $400, they have gone kind of up in this quadratic formula and then back down, and eventually they've reached zero money. They're not making any money anymore. Well, I am so sorry that this video is so long. I know there's lots of different situations where we use quadratics, lots of real-world examples. This has been a handful of those. Really, working these out is identifying what you need from the word problem, finding the numbers that go here, the numbers that go there, and then using the things that you already know. So you'll notice in this video that we factored, that we used the quadratic formula, that we used the square root method, but we had a contextual problem. And remember, it always helps if you try to draw out a picture of what's happening and hopefully it'll make more sense for you. So some practice problems to work on these and try to see how you can do. And I hope that you have a great time at it, and I'll see you in class.